Hi everybody, welcome back to my channel, Rockin' Dr. Rocks. So if you watched, well, it's been a couple of months now, one of my first videos I did one called Who's Dr. Rocks, or Who is Dr. Rocks, and kind of introduced myself. And I think in that video I said something about as winter starts rolling in, I may try to do some videos on minerals and looking at microscope views of minerals. I tried filming some of those here just this past week with my little camera, my little USB microscope, and I'm not really that excited about the quality of the video for some reason. When I am making the videos and looking at my computer monitor, the images are nice and crisp, and they look very sharp and they look great. And then I save the video and I play it back, and it looks kind of fuzzy and not quite in focus. And so instead of trying to put something out that doesn't look very good, I'm gonna keep working on this until I figure out how to make a video of these minerals that actually will show up. That I might put a small sample of one out there and wait for comments and feedback to see if it shows up blurry or a little off on your screens, or that's maybe just the way I'm seeing it. I don't know. So anyway, as winter is settling in, it's getting a little more difficult to get out and do hikes and film. I'm still going to continue to do that as I can. I hope to take you through the winter with us. So anyway, I'm going to try to continue to get out and make videos as I can. In the meantime, I think I'm going to try something else as well. I have my desktop computer set up with a software where I can actually record the images on my computer screen and then use that in a video and have audio over it as well. So what I'm going to think about doing, and I'm going to do this because I have an audience in my students that will like this content. And again, those of you that have subscribed, if it's not your cup of tea, then that's fine. But I'm going to go through some software packages and show how to do some really basic types of data analysis that, again, it might not be of interest of you, or you may think that it's not of interest for you until you see what it is. Because these things I'm going to show you are all online software packages that you can do yourself at your computer for free. And so I'm going to start with the U.S. Geological Survey, their website, which has a tremendous amount of information and data available for free, and software packages that you can do different things with that data. And so we're going to go through a series of videos looking at the repository, their particular site for data. And in particular, we're going to be looking at stream data, river data, flow data, some chemistry, water quality, those types of things. And I hope to show you these techniques can be, if you've never looked at this type of information before or never knew it was available, if there is a river or stream near you that has a gauging station on it, you can do all of these things and look at the current flow versus where it places in history statistically. You know, is it flowing at the 50% value? Is it flowing at the 95% value? You kind of get an idea of how the climate and the hydrology works in your area. So I think it might be interesting for those of you that have just been viewing, may not have ever thought about doing something analysis-wise on your own. I'm hoping to show you some simple tools that you will be able to do some of these things on your own. So this first video we're going to do today is just going to be looking at the USGS repository, seeing the types of data that are there, looking at some of the databases, and possibly doing a few real simple things. And then in future videos we'll get into actual the software, different software packages that you can enter data into and work out different scenarios for stream flow and flood recurrence and the water quality analysis and things like that. So I hope you find it interesting. I'm interested to see your comments. So always let me know what you think. And here I will now switch cameras and we will go to the computer screen and start this little journey. All right, thanks. See you in a bit. Okay, here we are at the U.S. Geological Survey's webpage, and it is simply usgs.gov, as you can see up here in the top of the screen. Up at the top up here are drop-down menus that shows the various things that they do, the science, and you can look up all the different types of science, different products, data and tools, their science catalog, maps, topographic maps, geologic maps, their publications, and imagery and those types of things. So, I have already, again, several videos ago, we looked at, or I've been using geologic map of the Black Hills, and I put a link in there to the geologic map, and it would come to this site here at some point, and then you could download that map. Okay, so today we're going to start with the Science Explorer tab and look at the various types of things that are cataloged here on the USGS website. And we're going to go into the Water tab and look at the things that they have in here. So one of the neat things that the USGS has maintained for over 100 years now is a network of stream gauging stations. And so let me go back to that first picture. So here's one stream gauging station, and this is on a pretty large river, it looks like, and these are automatic instruments that measure discharge at these various sites. And then all of this information from small streams to major rivers like this are made available online where you can access that. So here's all of the different topics in water that you can look at. Okay, so for this first video here, we're going to go into the stream flow, which should get us to the area where they house all of their discharge data from their stream gauge station. So I'll click on that, and the first thing that comes up is water data for the National Water Information System, or NWIS, NWIS. That's what all of us geeks refer to it as. So we'll click on that. Okay, so there's a lot of ways to start in here. You can use the map. If you know where you want, you can look at that directly. Current conditions is sites with real-time or recent data, and it will be surface water, groundwater, or water quality data. It could be all three, could be one or two, just depends on what's at that site. So let's go ahead and click on that current conditions, and we come up with a map of the United States. And from this point on, if we went back to that previous page and went into these other options, all the pages when you first get into them look similar to this right here, and where they have a map or some type of a drop-down box. Where here, here's all the things we can do on the. We're going to look at groundwater. We can go into stream flow, look at table data, precipitation. And we'll take a greater look at this at some point in the future, that, again, you can track precipitation on here and see how the precipitation at the current time is rating in terms of previous year and previous decades and over the record that they have for that station. Daily stream flow, that's one of the things we'll look at. But on this map right here, this is the nation, and the different symbols are explained down here. That just shows the stage of the flow. And so sites that are black, so up here around the Great Lakes and through the Northeast, they are very high flow. The blue dots are greater than the 90th percentile, so they're pretty high flow, and again, kind of peripheral to the black over on the West Coast as well. And then you get down to the warmer colors, the yellows and the reds, which is kind of most of the western interior. The mountain regions that have been kind of droughty, you can see that they're still droughty in here. South Dakota is right up here. I'm going to click on the state of South Dakota, and it will, and you can click on any state. So wherever you're at, you click on your state and you'll get a map of the current gauge stations with their current status. So right now at this scale in South Dakota, it does not look like there's any that are high. There's quite a few that are above the 90th percentile, and a bunch that are down in the where you'd expect it to be right now, 25th, in that area. And I think, I'm going to try to click here, see if it goes into the county. I don't think it goes in any further. Oh, it does go into a bigger map, so that's useful. Okay, because on that previous page, I was unable to distinguish a lot of these gauges here on the periphery of the Black Hills. So this is a map of the outline of South Dakota with the stream networks you can see in the kind of the gray shades on here. That doesn't show topography. The Missouri River flows in the center of the state from the north, and it comes down through the center of the state and then kind of tails off to the southeast and exits the state clear down at this corner of the state over here. The eastern part of the state is pretty flat. It's all glaciated terrain. The western prairie, which is all of this area over here, is kind of rolling hills. And then the Black Hills are kind of bounded by, it goes over into Wyoming, is kind of this area right here. And again, you can't see the topography of that. Rapid City is right in here somewhere. In fact, I just pointed to one, and that's the gauge, Rapid Creek above Canyon Lake. So that is about probably 4 miles from where I am right now, and it gives you this basic information. So it has the drainage area. So 374 square miles of area above this gauge station feed water into this particular location. The current discharge is 33 cubic feet per second. With a stage of 2 feet. So the discharge and stage are related, and the instruments out at the gauge station record both of those things, to where if you're recording stage, then you look at a chart and you can automatically calculate what the discharge is. Flood stage is at 7 feet, so you can see there's quite a lot of room here before flood stage yet. Whoops, let me get back. Class symbol is blue, which is 76 to 90, which means it's above normal, and it is flowing at, let me get back, 33 cubic feet per second is in the 76 to 90th percentile. So that is a real small flow, but it's above normal. So normal there is probably around 20 or something like that. And then all the statistics, I keep rolling off of this, sorry. So let's see, percent above normal, 220%, percent normal mean is 124%. So these streams are quite small, and so a small change in discharge in cubic feet per second can make a huge statistical difference on where that flow rests in terms of historical data. Okay, and one of the things about the USGS gauge stations is you see all of them have a gauge number. This one is 0641250. And when I routinely work with gauges and look at certain gauges periodically, I just type in that number from the first page at USGS, and it goes directly to the station, and instead of having to go through like I'm showing you. So I don't think I can click on it and it just tableizes the same thing. Maybe that's the best way to do it. Okay, the same data we just looked at. This has tabs, which is nice. So the hydrograph is a record of flow versus time. And so the time is on the x-axis down at the bottom, and then the flow is on the y-axis. And this is only for, let's see, October. This goes back days. So today's the 21st. So 1, 2, 3, 4, 5, 6. So the previous week. And you can see that the flow has been pretty consistent. Some little peaks and and things in here. And that could be, we've had depending on where you are locally in the area, a little rain, half-inch here. I had just a tenth at the house, and so you get runoff, and that could be some of these things in here. So a hydrograph can be constructed for any time period. You can construct a hydrograph for the entire record of this gauge station, which might be 80 years. You could do it for a month. You could do it for a year. You could do it for like this a week. You could do it for a day. You could do it over just a rainstorm. And it's a good way to look at the distribution of water through time past that station. Okay, peak flows are the highest values that are recorded at that site. And again, this is in stage and discharge. And so current 1026 today, 33 cubic feet per second. And let's see, this is 5/5, so May 5th of this year. At the start of the summer, it was 138 cubic feet per second. Back in 1972, 6/9, the June 9 flood, this station recorded 31,200 cubic feet per second. So you can see that's quite a bit above normal. And as I've already, I think, said in previous videos and alluded to, that one of the things that I'm working on for spring is a series of videos that takes us through the Rapid Creek drainage basin, looking at various parts of the system that were inundated by the flood back in 1972. And on June 9 of this coming summer, that'll be the 50th year anniversary. And so I have acquired all of the original data for this gauge station, plus 4 other stations on Rapid Creek through Rapid and above Rapid City. And I have all the original calculations on paper and everything that the USGS hydrologists work through. And we're going to take and look at this number and recalculate using their data and their methods and current other methods that you might be using today, and using stream morphology, or what the channel looks like today. I'm going to work through and look at where this flow rate falls in history. One of the big arguments and big points of discussion for the 1972 flood was, well, was it a 100-year flood? Was it a 500-year flood? Was it a 1,000-year flood? And I don't think anybody has really adequately addressed that. So I'm going to throw my hat in the ring this spring and look at this. So we will be looking at this gauge station particularly this spring. So that's what peak is just the highest flows. Forecast, this is National Oceanic and Atmospheric Administration, or NOAA. And it looks, I cannot see the screen, it's too small. And I probably can't make it bigger. Nope. So I'm not sure. Oh, click on it and oh, look at there. So these are all linked together. So this went right to NOAA and this website. And this is, again, this the past week, it looks like. And this is default hydrograph scale to flood categories. And this again is in stage. So we're down here at 2 feet, and it's been consistent over the past week. And so I see what it's doing. So 5 foot, then you go into the action stage. 7 foot is a minor flood. And so there would be various levels of probably warnings and those types of things that would happen if that happened. Okay, so I think we'll go back. Yep, and there we're back where we were. Okay, and the last one on here is the rating, and let's click on this and get to the rating curve. And again, and we will look at this with other sites. And again, this is something you can do. You can go into that national map, click on your state, click on a stream gauge or find a stream gauge near you, write that number down, and then you can go to these different tools and you can make all these plots and charts, everything that's shown over here on the left side of the page. So you can do things. You can look at flood, drought potential, runoff potentials, water year summaries, all these different types of information. And once you get there, if you come in through the gauge the way we did in this video, it will already be to your site. But if I had a piece of paper here with 5 or 6 stream gauge numbers on, I could sit and just put each one of those in here and look at all of those without having to go to that station. You just put the number in. You can set the size of your plots, 10 most recent measurements or water years. So various things, but this shows it's discharge for gauge height, and this is called a rating curve. And so the rating curve is built from actual measurements at the gauge site. So all of these gauge stations are automated. They have an automatic gauge. There's various styles and designs, but they record the discharge on increments, usually well, it might be every minute, or it might be pretty continuous, and then they're averaged on site, and every 15 minutes they send a signal through a satellite link to USGS headquarters in Reston, Virginia, and then that data is run through their algorithms and placed online, and within 15 minutes you can look up the most recent flow at any gauge station in the country. So they are continually measuring the discharge. The gauge height then is measured by people who go out and occupy each of these gauge sites a number of times a year, 2 to maybe 6, depends on what the gauge is on and what kind of river it is. And they'll measure the gauge height, correlate it to an exact discharge, and over time you get this curve that is built based on the flow measurements at the site. And so most of these gauge stations, if you find them, you will find a ruler, a yardstick, a pole with foot markings on it. And let's say you read 3.5 feet, you could come up to, get this rating curve, come up to the 3.5 foot. So 3, 4, there's 3.5, that first line, come over to this line. Oh, I picked a good one. It's right on a line. And we would be down here at 1, 2, 300 feet per second. Okay, so this is log scale, so keep that in mind. So it's tenths, 1, 10, 100, 1,000, 10,000, and then they chopped it at 40 because it hasn't been above 40. The highest in 72 again was recorded at 31, and that's not even on here because that doesn't count for the rating curve. But this is flow behavior for this river. Okay, so that's on this. So all that information can be obtained just by going in and clicking on that site. Okay, if I go in, let's see, and click on the county where I'm at, nothing happens. Okay, I'm in as far as I can go. Okay, so again, it gets pretty complicated. If I want to find a gauge in here, it's pretty difficult. It's hard to do. Okay, so let's go back out and let's come in a different way. So if you come to this main INWIS page, the waterdata.usgs.gov/INWIS, and if you do this or are interested in looking up this information, once you get here, come over here and bookmark this somewhere, so you can just come right back to this page. And you can look at current conditions, or if you hit the surface water tab, then you get historical data as well. So if we do surface water, here's all the options. The current conditions, there's 10,721 sites that have current conditions, 18,006 sites with historical observations, 28,877 sites with daily data, etc., etc. Now you may say, wait a minute, how come you have 29,000 sites with daily data and only 10,000 current? And that is because a lot of these are gauges that have they're no longer in play, they've been moved, and so this is a summary of everything that exists. So you might look up some of this information in here and you'll find data at a particular location from 1960 to 1963, and that's all that exists, but it will be in here. Peak flow, field measurements, all of these types of things. So, okay, so again, from this page, there's a lot of options in here. We're going to jump into daily data, which is one of the best ways to get to their entire record of what's going on now. And if, again, for new users particularly that might not have a list of stream gauge stations numbers, just hit state and territory and submit, and then select your state. And so for me, I'm going to go down to South Dakota, select that, and select nothing else. All these parameters are available, leave blank to select all. So as we scroll down through here, these are all the things. If there's information for any of these items in this data catalog, it will come back in the search. And here's the output. I'm going to check the first data range, which was, well, look at that, 1838. So I don't know what kind of measurements those are, but let's put it in just for giggles. 1838.01.01 and hit submit. And what this does is it comes back, again, we're in South Dakota. Yours is going to look different if you look up for California or Washington or Wyoming or Arizona, Texas, wherever it is you are. You will receive a list back of all of the gauges in your state. And they're going to be arranged, it doesn't say, but they're arranged by geographic area and kind of like basins. And so if you're familiar with that, you can kind of get those together, or you just look for the areas you're at. So in this area right here, Cheyenne River near Hot Springs, Edgemont, this is my area around the Black Hills, Hell Canyon, that's south of me about 50 miles. French Creek is about 30 miles south. Battle Creek at Keystone, this is another one we'll look at for the 1972 flood that had flood on it. There's its gauge number. And then we move a little further north to Cheyenne River, and then the Rapid Creek system. So starting up in the Black Hills with Castle Creek and moving down toward Rapid City. So Rapid Creek below Pactola Dam, above Pactola Dam. Rapid Creek above Canyon Lake. Here's the one we were looking at, 641-500. And then the other gauges through town, Rapid Creek, below Park Drive, all these ones in here. So this is just a list, again, of all the stations that are available. So we want to find Rapid Creek above Canyon Lake, and we'll just click on that. And that takes us into the site for this particular gauge. So they're all going to be listed like this, USGS gauge number with the gauge number listed, and then the name of the station, Rapid Creek above Canyon Lake near Rapid City. And so creek is usually abbreviated. And again, if you want to enter the name anywhere, you have to have that entire name. Okay, all of these are going to have a drop-down menu that shows what is available. You can look at it on a location map, current historical data, daily statistics, monthly statistics, annual statistics, peak stream flow, field measurements, field lab samples, what are your summaries. Okay, all of those are available just by clicking these various options. And so we're just going to stay on daily data. And if you don't see a record down here that has anything, just click go. If it happens to be blank, and it'll come up and it will show you the types of information that are available for that station. So here we have discharge measurements and we have gauge height. So again, from these two things, we could construct and build our own rating curve. And the data were available 1946. And then there was looks like there was well, that's to current. And that's to current, so something happened in that's the gauge height. So that only started in 17, apparently. And then we can output it as graphs or tables and tab separated tables, which we would use if we were going to download this data to do various things to it on the computer. So it comes up with again, kind of a hydrograph of the this previous year. So starting back in November of 20, and You can see, so this is log scale again for discharge in cubic feet per second. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100 cubic feet per second. So it started back in November, it was 20, 30, 40, about 52 or 3, hovering there, dropped through January through March, which is typical. And then runoff starts in March and then May. The big runoff, we get some rain, and it increases to 1, 2, 3, 4, roughly 400 cubic feet per second. It flowed for a little bit, and then it started dropping, and maybe another rain came in, and that's what all these little bumps are. So a lot of these are rain events. And now we've tailed off to where I think today was right now was 33, so 10, 20, 30, about 33. So that is where we are at. Okay, the height again is going to kind of mirror exactly what the discharge looks like. It's just a different measurement. This is the gauge height. This is the discharge. So that's what we want. Okay, so that's the USGS INWES page, water data for the nation. Really fun stuff. I just wanted to show you where that data was cataloged today. And again, like I said, this is going to be useful to my students as well. And then there's other things that we want to do looking at this data and how to actually assess the flow and the hydrology in your particular area. So thanks. Appreciate you watching for this channel. I ask that you hit the like button, subscribe if you haven't, share this with your friends. See ya.